Okay, guys, this is the density worksheet that I've uploaded that you need to work on. So if I were you, I would go ahead and write down this triangle right here. Mass, density, volume. All right, remember division is over here. Division is over here, okay? All right, so let's read this problem. A student finds a rock on the way to school. In the lab, he determines that the volume of the rock is 25 centimeter cube and the mass is 100 gram. All right, so my volume is 25 cubic centimeter. Mass is 100 grams. And we're looking for density. So density is going to be mass over volume. Remember, you covered the D. If you're looking for D right here, cover the D. It's mass divided by volume. All right, you come on over here. It's going to be the mass is 100 grams divided by 25 cubic centimeter. If you guys ever watch television shows that are medical dramas, they always talk about give me 1 cc of such medicine. That cc is cubic centimeter, which is also equal to 1 mil. All right, 1 cubic centimeter is equal to 1 mil. So 100 divided by 25 is going to be 4 grams over cubic centimeter. Notice density has both of these units. Okay, the next problem, number 2, is asking you to calculate for density as well, and that's going to be the same way. So I'm gonna scroll down right here, okay, and let's do this. Number 5, that is talking about a rectangular solid. Now you have to calculate. Notice part 2, it says solve for density of a regularly shaped object using volume. So you have to first calculate the volume, okay? So it's length times width times height. Very simple. So let's say a rectangular solid of unknown density is 5 centimeter long, 2 centimeter high, and 4 centimeter wide. So the volume is going to be 5 times 2 times 4, which is what? 40 cubic centimeter. All right, and then the mass is given to you, and that's 120 grams. Once again, you're looking for density. So the density is going to be right here, which is going to be mass is 120 grams divided by 40 cubic centimeters. So go ahead and put this. I went ahead and solved it because it's just the same formula. Density is mass over volume. I don't think we give you any problems where you actually need to calculate for mass or the volume. I think it's all just use calculating density. So 120 divided by 40 is 3 grams over cubic centimeter. Notice density once again has both mass and the volume units. You can do number 6. It's simple, same way. Let me scroll down here. Part 3, solving for density of an irregularly shaped object. Notice in part 2, it was regularly shaped object where you have all the length, width, and the height dimensions. Now it's an irregular shape. And if you have reviewed your density notes, you'll notice that there was a water displacement slide with the in a graduated cylinder. Okay, so I would go back and review that. All right, so it says a rock was placed in a beaker that originally contained 200 mils of water. So imagine, I'm going to do a drawing here just so that we can have, I don't know, somehow we can imagine this. Let's see. So this is my beaker. All right. Original volume was, this is where it was, 200 mil. All right. Then you ended up dropping a brick, does it say? Rock. After placing the rock in the beaker, the water level rose to 250. So now my volume from 200, actually, let me just erase this right here. Now my new volume from 200, it went up. right here when there was a rock. Okay, so this is at 250. It's showing 250 on my graduated cylinder, okay, or my beaker. So the difference or the volume that the rock displaced is going to be 250 minus 200, and that's 50 mils. Okay, that's the volume of the rock. So the volume of rock is 50 mil. Okay, and then the rock was placed on a scale and the mass of the rock was 300 grams. So mass of the rock is 300 gram. Once again, you have to calculate the density. Okay, so the density is going to be mass, which is 300 grams, divided by the volume that we just calculated, 50 mils. All right, this is how you're doing it. Please rewind this if you did not understand how to do this. Okay, so you're going to do 300 divided by 50, and you get 6 grams per mil. All right, notice when the water is being displaced, you're not just going to write down the total volume as 250. The total volume is final after the rock was dropped minus the initial where the volume was. Okay, so it's going to be 250 minus 200. Let me know if you are still confused about this, and we can I can upload another video about this. Okay, all right.